Welcome back to the deep dive. You know, I was reading through the packet you sent over, and I have to say, my perspective on my own laptop has completely shifted.
Oh, yeah? How so?
We usually talk about tech as these, shiny gadgets that make life easier. But today we're talking about warfare. We are
Mm.
talking about digital self-defense.
Mm.
And I don't just mean don't click on the sketchy email. I mean the actual architecture of survival in a digital world that is actively trying to break into your house.
It sounds a bit dramatic, but you're not wrong. When we look at the source material today, which is mostly based on CompTIA plus security standards, we're not just looking at settings.
Right.
We're looking at a blueprint for a fortress. Because the reality is the default state of the internet is hostile. If you connect a Windows machine to the web without defenses, it's not a matter of if it gets probed, but when.
Well, that's a cheerful thought to start the morning. So let's get into this blueprint. If I'm building a fortress, where do I even lay the first brick? The sources mention this concept, the CIA triad. Sounds like a spy thriller.
It is the foundation of everything. Seriously, if you're ever confused about why a security rule exists, I promise you, it traces back to one of these three letters, CIA.
Okay, so CIA, confidentiality, integrity, and availability.
That's it.
Okay, break that down. Confidentiality feels obvious, keeping secrets secret, making sure my neighbor can't read my diary.
Sure, that's the basic idea. But think bigger. Corporate, military, it means only authorized eyes see the data. If I email you a sensitive file and a hacker intercepts it, confidentiality is gone.
That's the spy part of the movie.
Right. But the second pillar, integrity, is arguably more important in some cases. Integrity isn't about secrecy. It's about trust.
Trust in what sense?
Trust that the data hasn't been changed.
Got it.
Imagine you send a digital contract to a client. It's for $500.
Okay.
A hacker intercepts it. They don't care what it says, but they change the 500 to 500,000 and send it on. The document arrives. It looks real, but the integrity is completely gone.
That is insidious. The message wasn't stolen, it was corrupted.
Precisely. And the third pillar is availability. This is the one people forget until it's too late. You can have the most secret, perfectly accurate database in the world. But if the power goes out or a hacker floods your network so you can't log in,
Then the data is useless. It's a brick.
it's a brick. A ransomware attack is, first and foremost, an attack on availability. They lock your files so you can't use them.
Yeah.
So every single thing we talk about today is trying to protect one of those three things.
Ideally, all three. Now, here's where I want to push back a bit. The old way of thinking was this castle and moat approach, right? Build a big firewall, and anyone inside the office is trusted.
Mm-hmm.
But the reading material suggests that model is totally dead.
It's worse than dead. It's dangerous. That model assumed the bad guys were outside.
Mm-hmm.
But what happens when the CEO gets infected at a coffee shop and then brings that laptop back inside the castle?
A Trojan horse.
Once that malware is inside the moat, in the old model, it could just run wild.
Hmm.
The network trusted it. And that is exactly why we've shifted to zero trust.
Zero trust. It sounds incredibly paranoid.
It is paranoid. But it's necessary. The philosophy is simple. Never trust, always verify. It doesn't matter if you're logging in from headquarters or a Starbucks. The system assumes you are a threat until you prove otherwise. Over and over again.
So it's not just showing your ID at the front door. It's like every time I go to the kitchen, a guard asks, "Are you really allowed to use the toaster?"
Basically, yeah. You try to access the finance server, we check you. Then you try to open the HR folder, we check you again. We verify your identity, your device, your location. It stops that lateral movement.
Which brings us to the mechanics of that checking process. The sources use the acronym IAM, Identity and Access Management. And I think for a lot of people, the terms identification and authentication feel like the same thing.
But they're completely distinct steps. Think of it like airport security. You walk up to the desk and say, "I am John Smith." That is identification. You're claiming an identity.
Okay, so identification is the claim.
Then the agent asks for your passport. You hand it over. That is authentication. You are proving the claim is true.
So identification is the username. Authentication is the password.
Exactly. But we're not done. Just because you are John Smith and you proved it doesn't mean you get to fly the plane.
That would be bad.
That is authorization. The system looks at your ticket and says, "Okay, John, you are authorized for seat 14B, but not the cockpit."
And finally, access control. Is the locked door actually stopping me?
That's the mechanism enforcing the rule. Now, this leads to a golden rule mentioned in the text called the principle of least privilege.
I love this concept. It sounds like a minimalist lifestyle choice, but for IT.
And that's a good way to think about it. It's the idea that a user should have the absolute minimum access necessary to do their job, and nothing more.
So a receptionist needs email and the calendar. They do not need admin rights to install software on the server.
Correct.
But wait, let me play devil's advocate. Isn't that just annoying? What if the receptionist needs to update Adobe Reader? They have to call IT. Wouldn't it be more efficient to just give them the power?
More efficient? Yes. More secure? Absolutely not. Because if that receptionist clicks a phishing link, and everyone clicks eventually, if they have admin rights, the malware now has admin rights. It can install itself, disable the antivirus, wipe the backups. But if they only have standard user rights, the malware hits a wall. The system says, sorry, no permission. The attack fails.
So inconvenience is the price of survival.
In security, convenience is almost always the enemy.
But what about the IT pros? They need those superpowers. The notes mentioned something called JIT, just-in-time access. This sounded really cool to me.
It is cool.
Yeah.
Because even for me, walking around with a God mode account all day is dangerous. So JIT solved this.
Yeah.
Instead of having a permanent admin account, I request access for a specific task.
So you say, I need to fix the email server.
Right. And the system says, okay, granted, you have administrator powers for exactly 60 minutes. Go. I do my work. When the clock runs out, my powers vanish. I turn back into a pumpkin.
That's brilliant. So there's no admin account just sitting there waiting to be stolen.
Exactly. It reduces the attack surface. You can't steal credentials that don't exist.
Okay, I want to pivot to the secret language part of this. Encryption. The sources break this down into symmetric and asymmetric.
The math that keeps the modern world turning.
Let's start with symmetric. The analogy was the box and key.
Symmetric is the workhorse. It's fast. It uses a single secret key to both lock and unlock the data. I have a key, I put the data in the box, lock it, send it to you. For you to open it, you need the exact same key.
And the problem that immediately jumps out at me is, how do I get the key to you? If I email you the key, the hacker who steals the box also gets the key.
You've just hit on the key exchange problem. Symmetric encryption is great for speed. We use it for Wi-Fi, for encrypting hard drives with the AES algorithm. But it's terrible for sharing secrets online.
So that's where asymmetric encryption comes in. This is where my brain usually starts to cramp up. The notes use a mailbox analogy. Walk me through this.
Okay. Imagine a regular mailbox on the street. Anyone can walk up and drop a letter in the slot. The slot is the public key. You give that to everyone. You tell the world, if you want to send me a secret message, drop it in this slot.
Okay, so anyone can encrypt a message to me. But once it's in the box...
Can the person who dropped it in get it back out?
No. You need the mailman's key to open the whole thing.
That is the private key. Only you have that. So I can send you a message using your public key, knowing that only you can decrypt it with your private key.
That solves the exchange problem. I don't need to send you a secret key. I just shout my public key from the rooftops.
Exactly. But there's a catch. Asymmetric encryption is, well, it's slow. Very slow. The math is incredibly complex.
So we can't use it for everything.
Oh, no way. So we cheat. We use a hybrid approach. When your browser connects to a secure website, HTTPS, it uses the slow, secure asymmetric encryption for just a second.
Just long enough to do what?
To safely swap a symmetric key. Once we both have that key, we switch over to the fast symmetric encryption for all the heavy lifts.
Wait. So it's the best of both worlds. You use the armored truck to deliver the key, then the race car to deliver the data.
That is a perfect analogy.
Now, one more term here that I think people confuse with encryption all the time is hashing. The source material was very clear. Hashing is not encryption.
No, not at all. Encryption is a two-way street. You lock it so you can unlock it. Hashing is a one-way trip. It's destructive by design.
The analogy was a blender.
Yes. If you put a strawberry and a banana in a blender, you get a smoothie. You cannot push a button and turn that smoothie back into a strawberry.
Okay, but why is that useful? If I can't get the data back, why do it?
Passwords. That's the main reason. When you create a password for a website, say my secret password, that website should never, ever store that phrase in their database.
Because if they get hacked, the hackers have my password.
Right. So instead, they put your password into the blender, a hashing algorithm like SHA-256. It turns my secret password into this long string of gibberish called a digest. And they only store the gibberish.
So they don't even know my actual password.
Nope. When you log in, you type your password, they throw that into the blender, and they just compare the two smoothies. If they match, you're in.
And this brings up the avalanche effect, right?
That's what makes it so secure. If you change even one character, like you type my secret password.
Yeah.
With an exclamation point, the resulting hash looks completely different, utterly unrecognizable.
Fascinating. So, we've encrypted the traffic, we've hashed the passwords. Now let's talk about proving who we are. We need to talk about MFA, multi-factor authentication.
This is the single most effective security measure any user can possibly take.
We've got the 5 factors listed.
Yeah.
Something you know, like a password. Something you have, like a phone. Something you are, a fingerprint. Somewhere you are, GPS. And something you do, like typing speed. But the critique in the notes is that people do this wrong.
We do.
Yeah.
True MFA requires 2 different categories. If I ask for your password, something you know, and then a PAN, which is also something you know, that's not multi-factor. It's just 2 passwords.
It's redundant, not layered security.
Exactly. You need a password, something you know, and a fingerprint, something you are. Diversity is strength here.
Let's zoom in on something you have. Most of us use our phones, right? We get that text message with a 6-digit code. But I've been hearing that SMS is actually risky now.
It is better than nothing, but yes, it is the weakest form of MFA. The risk is SIM swapping.
How does that even work?
A hacker calls your mobile provider, pretending to be you. They say, hey, I lost my phone. Please move my number to this new SIM card I have.
Yeah.
If the support agent believes them,
My phone goes dead.
and their phone starts ringing, now they get your text messages, including your bank's verification codes.
That is terrifying. What's the alternative?
Authenticator apps, Google Authenticator, Microsoft Authenticator, they generate the code on the device itself. It never goes over the cellular network, so even if they steal your phone number, they don't have the app on your physical hardware.
Okay, everyone listening, go switch to an app.
Yeah.
Right now. Seriously. Now, speaking of hardware, Windows. Hello. I use the face scan every day. But the notes made a claim that confused me. They said a simple 4-digit PIN can be safer than a complex password. How is 1234 safer than some 20-character monster?
It feels wrong, doesn't it? But it's all about architecture. When you type a password, that password gets sent across the network to a server to be checked. It's in transit.
Okay.
A Windows Hello PIN. Hello PIN is tied to the specific hardware of your laptop. It lives inside the TPM, the Trusted Platform Module chip. The PIN never leaves the device. When you type it, the chip on your motherboard validates you locally, and then the chip itself tells the server, hey, he's good.
So if a hacker steals my PIN...
It's useless to them. They'd have to physically steal your laptop and know the PIN. The PIN just unlocks the local chip. It separates the credential from the network.
Wow. That makes me feel much better about my PIN.
It should.
Okay, we're coming into the final stretch. We've covered the user side. What about the admin side? If I have 500 employees, I can't be setting permissions for them one by one.
You'd go insane.
Yeah.
That's why we use groups and organizational units, or OUS. You don't give Bob permission to the accounting files. You create a group called accounting, give that group permission, and just drop Bob in the bucket.
Scalability.
And consistency. Bob leaves, you just take him out of the bucket. Done.
Now, there's one specific power move I found in the notes, a command line trick .net user, and there's a specific flag you can add. Logon password, thg.yes.
Ah, yes. The force change flag.
It looks like alphabet soup, but what's the philosophy here? Why is this so important for an admin?
Because if I, the admin, set your first password to welcome 123, then for a moment, I know your password.
Which means if I do something bad, I can maybe blame you.
Exactly. Or a rogue admin could log in as you.
Yeah.
By using that flag, the system forces you to change the password the very first second you log in.
So the temporary password dies instantly.
And you create a new secret that even I, the admin, don't know. It reestablishes privacy, it protects the user from the admin, and the admin from liability.
It's a clean handoff. I like that. So we've covered a massive amount of ground here.
We have, from the CIA triad to zero trust, through encryption, all the way down to the hardware chips.
But you can see how it all connects. It's defense in depth. That's the term, right?
Right. No single layer is enough. You need the physical locks, the technical controls like MFA, and the administrative policies like groups. You need all three, because eventually one of them will fail.
And the human element.
The human is always the glitch in the matrix. You could have the best firewall in the world, but if someone holds the door open for the pizza guy who's actually a hacker, you lose.
That brings us all the way back to that haunting idea of zero trust. We started this talking about building a fortress, but it seems like the modern fortress is invisible.
In a way, yeah. We used to rely on physical boundaries. I am in the office, therefore I am safe. Now with the cloud, with remote work, the office is everywhere.
And nowhere.
Which leads to a sort of existential question for us. If we move to a world of perfect zero trust, where every request is challenged, every packet inspected, and no device is ever truly trusted. Are we losing something?
What do you mean?
Well, we're moving toward a reality where your physical location and your physical device matter less and less. You are just a floating identity, a collection of credentials and biometric hashes suspended in the cloud.
Huh.
If you lose those credentials, do you, in a digital sense, cease to exist?
That is a heavy thought. We're becoming ghosts in the machine.
Let's just make sure those ghosts have multi-factor authentication enabled.
Deal. Thank you so much for breaking all this down. This was a real eye-opener.
Quite pleasure. Stay safe out there.
And to everyone listening, check your passwords, get an Authenticator app, and maybe look at your toaster with a little more suspicion today. We'll see you on the next deep dive.